Hi everyone, in this video, I'm going to be talking about linear regression using the PyTorch and NumPy libraries in Python. Now, linear regression in statistics, we use it to predict a continuous value. And a continuous value, for example, you can see right here is the distance of a galaxy, how far it is away from us, and the velocity is the one that we try to predict how fast it is moving away from us right here. This right here basically shows us that the universe is expanding, okay? And the linear regression formula is similar to the line slope intercept form that many of us are familiar in math, which is y equal to mx plus b. You can see right here, right? Here is the regression formula, except for the error term right here, right? It's very similar, okay? So in order to do linear regression, we first need to import the NumPy and the PyTorch library. We also going to import the matplotlib for data visualization. Okay, so here are the data. There's about 23 data pair, x and y, distance, how far a galaxy is away from us, and how fast it is moving. And you can see right here, right, the farther it's away, the faster that it is moving. Okay, so the first thing we're going to do is that we're going to put this data into the variable distance and the variable velocity right here. Okay, we also going to find the max distance and max velocity. Max distance, max velocity right here. The reason is because we're gonna need to kind of renormalize this number a little bit so that it will work well in the neural network model of PyTorch. Okay, and then for visualization, I'm doing a scatter plot of distance versus velocity right here, and with the title Herpes law right here. And you can see that there's generally a linear relationship between x and y, or distance and velocity. At this point right here, I am dividing the data by its max value just to normalize the data a bit so that it will work well, work better in the PyTorch library. Okay, and then we have to convert it to a tensor type right here, and then we also have to reshape it into a one column vector, and in this situation is 23. Okay, and you can see right here, right here is the shape of distance t. Distance t stands for tensor, and then velocity t, tensor, shape right here, 23 and 1. So when we have the data ready, we can create our model, which is just a simple a linear model using the neural network in PyTorch. And then the in features, basically we only have one variable coming in, and then we only have another variable coming out, distance, velocity right here, right? And you can see that here is our the model, linear, and the bias by default is true. Okay. Next thing we're gonna do is we're gonna set the learning rate, and we're gonna choose the loss function. Right, the learning rate I choose is about 0.05, and the loss function I'm using the mean square error, okay, of the PyTorch library, and then for the optimizer, I'm just using the stochastic gradient descent and passing the parameter of my model and the learning rate. Okay, this for loop right here is where the learning is the model is actually doing the learning right here. So for each iteration, we gonna predict the value using our model right here, and then after each prediction, we gonna calculate the loss using our mean square error loss function right here. So here's the actual data, here's the predict data, here's the loss function, and for each iteration, I'm storing this loss function right here so that we can visualize how it changed over each iteration. Okay, and this step right here is where we do backward propagation to relearn, to let the model relearn and get a new prediction. So we set the gradient back to 0. We do backward propagation right here, and then this one right here is just for book skipping right here. Okay, and here this step right here is where we visualize the losses. You can see right here, right? It learned pretty quickly. It's dropped down to this values right here, and then the learning decreased. The learning is really fast over here, and it's decreased over here. So maybe a 300 iteration for this learning rate would be good enough. Okay, so here is the number of iteration. Okay, and then for this one right here, I calculate the I'm taking each losses, okay, and then I plot that right here, and then the final predicted value is the red dot right here. Okay. Now we can look at the individual parameter from the the final app loss by just using the item function method right here, right? So the final app loss is about 0.02, and then we can also calculate the correlation of coefficient by passing the actual data and predicted data right here. Okay, from this we can find the R statistic by going into the particular element of the array. In this situation, 0 and 1 right here. Okay. So here is the plotted data versus actual data right here. Okay. Right here. Okay. And then we can get the slope from this about predicted model to calculate the age of the universe right here. So from our model, we can get out the parameter W and B, and the W is basically the slope, right? But we have to renormalize it back to our original scale so that it would work. And in this situation right here, the slope calculation is 74. And the age of the universe is basically the inverse of this one right here, and then convert it into year. And this formula right here is just invert that. So it's going to give the age of the universe in second, and we have to convert that into year, right? So according to our neural network model, our age of the universe is about 13.1 billion years. Okay. For a simple model like this right here, we could also use NumPy, which actually is a bit more straightforward and efficient. And you can see right here, right? We had the two values again. We pass the x and y into the polar fit function method of NumPy, and then 1 is just for linear. 2 is for example to the second power. And then if you see right here is the slope, the Hubble fit parameter. It's going to return the slope and the intercept point right here. Here is another visualization of this polar fit line, the red line right here, with the data. Okay, and then using the inverse of the slope, Hubble fit 0 right here, we can also find the age of the universe as before, and we calculate that it is about 12.1 billion years with the NumPy method. Okay, so here is an example of linear regression using actual data from Hubble data in NumPy and PyTorch. I hope that you find this video helpful. If you do, please give a like, give a thumb up, subscribe, and have a good day.